Hi, Assalamualaikum and a very good morning. So now we are in chapter 8, which is the hydroxy compound. We're going to focus on the subtopic of 8.4, which is chemical properties, part 1 of the video. So in this video, we're going to look into the reaction of alcohol with reference to the sodium. So this refers to a sodium metal. Also, we're going to look into the reaction of alcohol with carboxylic acid in order to produce an ester. And this process is known as the esterification. And we're going to also look into the dehydration of alcohol, which is this is the similar thing as what we have learned in the chapter of alkene. Okay, and last but not least, we're going to look into the substitution reaction using alkyl halide or penta or phosphorus trihalide or phosphorus pentahalide or using a sodium dichloride oxide, where the X here refers to halogen and it can refers to chlorine or bromine in this case. Okay, so it can be PCl3 or PBr. Okay, and for part B, we're going to look into the oxidation reaction using potassium permanganate, sodium dichromate, potassium dichromate, chromic acid, as well as using the pyridinium chlorochromate, which is a mild oxidizing agent. Okay, other than PCC, this is known as the strong oxidizing agent. Okay, so without any further ado, let us start. So for the reaction of alcohol, it will involve two types of bond cleavage. So first we have OH bond cleavage, where O and H bond gonna be broken down. O dengan H bond akan diputuskan di sini. Ataupun it gonna involve a COH bond cleavage, where C and OH gonna be broken up here. So the reaction that involve OH bond cleavage is reaction with sodium, esterification, and oxidation. The reaction that involves COH bond cleavage is going to include dehydration as well as the substitution reaction with all of these substances here. So let us look into the reactions that gonna involving the alcohol. Okay, so first we're gonna have the reaction with sodium. So in aqueous solution, alcohol gonna act as a very weak acid. So alcohol which acting as a very weak acid, gonna have a reaction with sodium, which is an alkali metal, at room temperature, and this is going to produce an alkoxide ion, where OH bond here going to be broken down, and RO become negative, and sodium is a electropositive metal. Okay, and this is going to produce an alkoxide salt. So RO minus here refers to alkoxide ion, and when there is a metal, it's going to produce a salt. And as the byproduct of the reaction, hydrogen going to be released. Okay, another example for this is, let's say if we have an ethanol here. So ethanol, which is a very weak alcohol, can react with sodium metal. Okay, sodium metal act as an alkali metal. They are in group 1 of the periodic table. So acid and base can react together in order to produce an alkoxide salt. And this happens at room temperature, where the OH bond here gonna be broken down, and this gonna carry this side here, which is the alkoxide, gonna carry a partially negative charge, and the sodium metal, which is electropositive, gonna be carry a positive charge here, and the byproduct gonna be known as the hydrogen gas. So this structure here is known as sodium, and here refers to the alkoxide ion, which in this case it is known as ethoxide because it has 2 carbon chain. Okay, and this reaction basically shows the acidic properties of alcohol. Okay, so alcohol can react with sodium metal. However, alcohol cannot react with sodium hydroxide. Okay, so sodium it can occur, but sodium hydroxide it cannot occur because it is a very weak acid. So the reaction does not proceed. Okay, now we're going to look into the esterification. So for esterification, the alcohol going to react with the carboxylic acid under reflux, and it is catalyzed by the acid, which is the sulfuric acid, in order to produce an ester. Okay, let's say if you have an alcohol and then you have a carboxylic acid here. So with a catalyzed reaction at under reflux at high temperature, you're going to produce an ester. Okay, so as what you can see here, the hydrogen going to be removed from the alcohol, and OH group going to be coming out from the acid here. Okay, and this is going to produce a water, because HOH is the same as H2O. Okay, and R1 going to be attached to the carbon double bond R2 here. Okay, this RO here. Okay, so this thing is coming from here, and this is going to be attaching with C double bond O R2, and the byproduct going to be the water. Okay, so now let us look into the example here. Let's say if we have a methanol, and then we're going to react that with the ethanoic acid, and under catalyzed reaction with reflux, what we're going to produce is an ester. And as mentioned, for the alcohol, the hydrogen here going to be removed, and for the acid, OH here going to be removed as a byproduct of water. Okay, and CH3O here going to be attaching to this side here. So let us do that. So once you do that, you're going to produce a methyl ethanoate, and the byproduct going to be the water. Okay, so this side going to be attaching with the carbon here. Okay, so this is known as ester. Okay, and for the naming of ester, you're going to name the alcohol first, which is methanol, so it's going to be methyl. And for the carboxylic part, you're going to change the name from oic acid into become OATE. So that is why it become ethanoate. Okay, so for the ester, it's going to become ethanoate. Okay, so you will learn more about this in the chapter of carboxylic acid, which is chapter 10 for the semester 2 program. Okay, and also you can also draw it as CH3O, C double bond O, CH3. Okay, so it is the same thing. So yeah, you can also draw it in terms of this way, or you can also put it on the right hand side, because it is still bring about the same meaning. Okay, now let us look into another example. Let's say if you have a cyclohexyl methanol, and then you're going to react that with an acid of 2-methyl propanoic acid. Okay, 1, 2, and 3, and 2-methyl propanoic acid here. So for the alcohol, you're going to lose the hydrogen, and for the acid, you're going to lose the OH here. So in order to produce an ester, the oxygen going to be bonded with the C double bond O here. So under reflux and using acid as a catalyst, what we're going to produce is that the alcohol group going to be attaching with the double bond O here. Okay, so this is going to produce another bond here, and this is going to produce an ester. So for the naming of ester, you're going to name the alcohol first. Okay, remember A first, then only C. Okay, so the alcohol part is the cyclohexyl methanol. But now, because it become an ester, so it's going to be cyclohexyl methyl, and because this one you're going to change it into YL, and for the acid part, OIC acid, you change it into OATE. Okay, so it's going to become cyclohexyl methyl 2-methyl propanoate. Okay, so this you're going to learn in the chapter of carboxylic acid, which is you're going to name the ester. Okay, but I'm just going to introduce you now so that you get a head start of the chapter. All right, now we're going to look into the third reaction, which is the dehydration. So for the dehydration, we're going to eliminate water from the alcohol. So let's say if you have an ethanol, and then you're going to use the concentrated H2SO4, and this happens at high temperature. So what you're going to do is you're going to remove water from the alcohol in order to produce an alkene. In this case, it is known as ethene because it have 2 carbon bonds. And here, water is going to be removed as the byproduct. So now let us look into another example here, which is 1, 2, 3, 4, which is a 2-butanol. Okay, so this is the reaction of 2-butanol reacting with concentrated H2SO4. So what you're going to do is the dehydration. So you can remove HOH here in order to produce a double bond here. So at high temperature, this is going to eliminate the water, and carbon-carbon double bond going to be produced here. Okay. At the same time, you can also select on this side here. Okay, so if you remove OH and H here, carbon-carbon double bond going to be producing at this side. Okay, and you will have two kind of product. So one going to be the major product and one going to be the minor product. So the above here going to be the major product because it is a more substituted alkene. The carbon-carbon double bond, for example, here going to be attaching with 1 and 2 alkyl group. Meanwhile, for here, this one have none, and this carbon here going to be attaching with 1 alkyl group. So here got 2, here got 1. So here going to be major product, and this going to be the minor product. And this is following the Stay-Safe rule. The same thing as what you have learned in alkene. Okay. Now we're going to do the substitution reaction where the alcohol will undergo substitution with the haloalkane, for example HX, or phosphorus trihalide PX3, or pentahalide. So penta means 5. Or they can also undergo a substitution reaction with sulfur dichloride oxide, or the other name of this one is thionyl chloride. So the naming here is very important because sometimes in exam they don't give you the structure here. They just say that the substitution reaction happens with the presence of thionyl chloride. So you need to be able to know the structure. Okay. So as mentioned, the X here can be halogen, for example, chlorine or bromine. So this happens via the conversion of ROH into RX. Let's say if you have alcohol here, and then via the reaction of PCl, you're going to change your OH into Cl. Okay, from OH it becomes X here. Okay, so now let's look into the reaction, the substitution reaction with haloalkane. So first you have alcohol, and then you're going to react that with haloalkane. So what's going to be done here is that OH going to be replaced with X here, and water going to be removed as the byproduct. OH substituted with X. So example, if you have this kind of alcohol, and then you're going to react that with the hydrochloric acid, OH here going to be replaced with Cl. And the byproduct of the reaction going to be water. Okay, and now let us look into another substitution reaction, which is using the trihalide or pentahalide. Okay, so the alcohol can react with the PX3, which is the trihalide, in order to produce haloalkane, which is RX, and the byproduct here H3PO3. Okay, the same goes to here, which is the alcohol can react with pentahalide, where OH here gonna be replaced with X. Okay, similar reactant produce the similar product. Similar reactant produce a similar product, but the byproduct here is different. So at this point, you need to be able to know the byproduct, because sometimes in the question they will give you the byproduct and they will ask you to determine the reactant here. Okay, so it is important for you to know the byproduct. So if the byproduct is H3PO3, it means that you are using PX3 here. Okay, and the 3 here is acting as a stoichiometric coefficient. So because you're using PX3, and then you need to balance the X here, so you're going to put 3 here and 3 here in order to balance it out. For this one, you have X5, right? So it's going to be X plus X3 4 plus X1, so it's going to be X5. So it is balanced. Okay, now let us look into the example here. So let's say if you have an ethanol, and you're going to react that with PCl3, where X here, I change it into chlorine. So OH here going to be changed into Cl. Okay, and this is going to produce the byproduct of H3PO3. So this one is important. Okay, because it contains 3 Cl, so I'm going to balance it out with a 3 here and put another 3 here. Okay, and as what you can see, this general reaction is the same as the reaction here. 3 alcohol, 3 mole of alcohol, PX3 PCl3, 3 haloalkane, and H3PO3. Okay, and for this one, which is alcohol, and then you're gonna react that with the PBr5, where X gonna be bromine, and once I do that reaction, the OH gonna be changed with bromine, and then the byproduct gonna be POBr3 and HBr. Okay, so Br got 5, so Br1, Br plus 3, 4, plus 1, 5. So it is balanced. Okay, and the byproduct here is important to be known. Alright, now we're going to look into the third part of the substitution reaction, which is the reaction using sulfur dichloride oxide, or the other name is thionyl chloride. So it is important for you to know this, and this is indicated by a structure of SOCl2. So alcohol can react with this thionyl chloride, and OH here going to be replaced with Cl. Okay, and this is going to produce a haloalkane, and this is going to produce sulfur dioxide as well as HCl. Okay, and this happens in the presence of pyridine as the solvent. So pyridine here is compulsory to write. So alcohol react with SOCl2, and OH here gonna be replaced with Cl. Okay, and this happens in the presence of pyridine, and OH going to be replaced with Cl, and the byproduct going to be sulfur dioxide and HCl. And as mentioned, pyridine is needed when SOCl2 is used. Okay. Now we're going to do another reaction, which is the last reaction of alcohol. So alcohol will also undergo oxidation, where the oxidation of alcohol will yield a carbonyl compound, which can be aldehyde, ketone, or carboxylic acid. So this is depending on the class of the alcohol. Okay, so the order of reactivity towards oxidation reaction gonna be the primary alcohol gonna be more reactive than the secondary alcohol, okay, and more reactive than tertiary alcohol. So the primary alcohol is more reactive towards oxidation reaction because it has more hydrogen, where it can be used in order to undergo oxidation reaction. Okay, and for the below part here, I'm going to show you the common oxidizing agent. So for the mild oxidation agent, we have PCC. So PCC represent pyridinium chlorochromate, and this must happen in the presence of inert solvent, which is dichloromethane. Okay, so mild maksudnya tidak begitu kuat, yang sederhana ataupun oxidation agent yang lemah. Okay, so for mild oxidation agent, we have PCC in dichloromethane. For the strong oxidizing agent, we're going to have the potassium permanganate, which is KMnO4, with heat and acidic condition. Also, we're going to have the chromic acid, which is H2CrO4 or CrO3H+, or we can use sodium or potassium dichromate here. Okay, so this two is known as the strong oxidizing agent. Only PCC is the mild oxidation agent. Okay, so now let us look into the reaction of alcohol. So for the primary alcohol, it can be oxidized to aldehyde or carboxylic acid by using a suitable oxidizing agent. Okay, so carboxylic acid can be obtained bila kita menggunakan a strong oxidizing agent, for example, KMnO4 or the chromic acid. Okay, so from the primary alcohol, when we react that with the strong oxidizing agent at high temperature and with acidified condition, what we're going to produce is a carboxylic acid. Okay, but now when we are using a primary alcohol, but we are using PCC, which is the mild oxidizing agent, what we're going to produce is an aldehyde. Okay, so kalau menggunakan strong oxidizing agent, you're going to get carboxylic acid. If you're using mild, you're going to get aldehyde. So let's say if you have a primary alcohol with PCC, which is the pyridinium chlorochromate, with the presence of inert solvent, which is the dichloromethane, what you're going to get is an aldehyde. Okay, So this is the carbonyl and it is attached with hydrogen. Carboxylic acid, we're going to have OH here. Okay. Now for the oxidation of the secondary alcohol, we can use any type of the oxidizing agent and the secondary alcohol will produce ketone. So let's say if we have a secondary alcohol and then I'm going to use a strong oxidizing agent which is KMnO4 in the presence of high temperature and acidified condition, what I'm going to produce is a ketone here. So ketone is a carbonyl group attached with two of the alkyl group here. Okay, and for the tertiary alcohol, it cannot be oxidized. This is because there's going to be absence of the hydrogen atom at the carbonyl carbon, which is the carbon that attached to the OH. So as what you can see here, the tertiary alcohol does not have any hydrogen, so they cannot be undergoing oxidation. Okay, tertiary alcohol undergo oxidation and there will be no reaction because the carbon here with OH group is already bonded with 3 alkyl group, so they cannot remove the hydrogen and they couldn't form the C double bond O in order to produce ketone or produce a carboxylic acid or an aldehyde. Okay, so this is the summary of the oxidation reaction that I have talked just now. So for primary alcohol, using a strong oxidizing agent, it's going to produce a carboxylic acid. Okay, so C double bond O OH. For using a mild oxidizing agent yang lemah, what we're going to produce is an aldehyde. Kurang satu oksigen. And this is known as the aldehyde. Okay, so primary boleh produce carboxylic acid, primary boleh produce aldehyde depending on the strength of the oxidizing agent. For secondary, it will always produces a ketone, and for tertiary, there will going to be no reaction. Okay, so I think that's all for today's video. See you again some other time. Bye!